Hey folks, it's Dan Wilson. I'm with Blues Wireless. We're the fastest path to cellular IoT. And today I'm catching up with Brandon Satrom, VP of Developer Experience at Blues Wireless, who was at the IoT Evolution Expo in Miami. Hey Brandon, how are you?
I'm doing great, Dan. How are you?
I'm doing fine. For the folks at home, give them the who are you and what do you do?
So, yeah, thanks. I am the VP of Developer Experience for Blues Wireless. So, I lead our developer engagement teams, both content creation and developer relations, as well as marketing and really most of our go to market activities around helping and enabling our customers to build applications with cellular and wireless IoT solutions.
Sounds like you have quite the handful. And speaking of which, you presented recently at the conference on making cities smarter with tinyML and cellular IoT. Can you walk us through your presentation topics and what you got out of the show?
Yeah, absolutely. So it was a really interesting conference, really excited to be back in person after almost 15, 16 months of doing primarily virtual events. And so it was a great event. And I had the opportunity to give a talk on, yeah, smart city opportunities, especially around Edge ML and cellular IoT. And I would say probably the real TLDR of the session itself was that when it comes to building smart city applications, I think one of the largest challenges in existing applications and deployments today is how you can build privacy protecting applications, right? There's a lot of examples out there of smart city deployments that either harvest user data so that the city or the municipality can actually deploy something, or cases where facial recognition and other associated, personal detection technologies are being streamed to the cloud. And so I really wanted to frame this in the context of two different technologies that together actually work really well for smart city applications. And the first was tinyML or Edge ML, this idea that it's becoming increasingly popular to do machine learning and possible to do machine learning on microcontrollers and on single board computers that are actually deployed in cities or at the edge or where an application is actually running. So where this is useful in the context of something like facial recognition is that if you're building an application that uses traditional facial recognition technologies, you have to stream video or images to the cloud. So you're streaming something that is built in personally identifiable information of a person that you're tracking, a person or persons. And that data may not be kept. It may be deleted ultimately once it actually does its thing, but it is being transferred over the open internet many times. And so it's an attack vector. And honestly, in many cases, something that citizens aren't really given an opportunity to express their support for, right? There's a lot of times citizens haven't given their cities the thumbs up to deploy cameras everywhere and do do cloud-based machine learning. EdgeML takes the approach differently. And what EdgeML gives you the ability to do is actually make a decision without sending data over the cloud. And this is important because most of the time when we're building machine learning algorithms, machine learning applications, we're not trying to get the raw data. We're trying to get a decision, something about it, right? We're trying to determine, is someone crossing the street right now? Not who that person is. We're trying to determine what's the prevailing emotion among this crowd of people. We're not trying to detect and identify every single face by and large. And so with EdgeML, we get the ability to actually get the thing we want out of our application without streaming video data, without streaming images up to the cloud. We can just send the results, the emotions, the number of people in a crosswalk, whatever it might be, the actual thing that we're looking for to build our application around, rather than the raw data itself. And so that ends up being very much more privacy respecting and really appealing to a lot of municipalities. But the other benefit of this, and this is where cellular IoT comes in, is that Edge ML reduces the amount of data that you're sending across the pipe. A lot of cities are building applications where they're offering broadband access to their citizenry, or they're trying to offer broadband credits to businesses. And if you're building an application that streams high resolution video, data, and images, you're using a lot of that pipe that businesses and communities are actually sharing. So with EdgeML, again, you send less data because you're just sending the end result. And what this allows you to do is build applications that can then use a technology like cellular, which tends to be lower data packets because you're not sending images, you're not sending video, you're just sending the results. You can use cellular IoT to actually deploy an application without having to set up infrastructure, without having to buy gateways or rely on Wi-Fi or Ethernet or things like that. And so That was my, I think, 3 or 4 minute summary without restating the entire talk, but it's a really interesting, very engaged audience, and I enjoyed it.
Yeah, it sounds fascinating. So the takeaway is if you're building a smart city and you're concerned at all about privacy of your citizens or the efficiency of your networks, consider tinyML and the cellular networks. Brandon,
Absolutely.
really a pleasure. Thanks for joining us today. See you next time.
Thanks, Dan.